today's Python video, we're going to be taking a look at the standard error. We're going to be going through 4 different examples. The first example is going to be a manual calculation. Then I'm going to show you how SciPy makes this super easy. And we're going to close out the video by plotting a graph showing different sample sizes and the standard error associated with them. But before we jump into our Python code, I want to go over a little bit more background information on what the standard error is and how we can use it. Okay, let's take a look at the standard error of the mean. So according to the central limit theorem, sample means are going to be normally distributed, and the standard error measures the standard deviation of the sample means. So the formula is calculated by dividing the standard deviation of the sample by the square root of the sample size. And you'll see the standard deviation, either S or sigma in this formula. It's STD for standard deviation. And N is going to be your sample size. Now, the smaller the standard error, which means the mean is more accurate, and standard error decreases as the sample size increases. And you can find the standard error from a single set of measurements. Now, the graph over here, the standard error versus sample size, we're actually going to be plotting this in the video, so stay tuned for the Python code for that, as well as this down below, right, which shows the sample size 50, 500, and 5,000, the standard error 351, 13042, and then the sample mean 242, 240, and then also 240. Where are we going to use the standard error? Well, we're going to be using it in the next video in the series, which covers confidence intervals. So your confidence interval is going to be your sample mean plus or minus the standard error of the sample mean times the t or z value. We'll cover those also. Now, here's a quick example for you guys. All right, let's imagine we have test scores 72, 82, 85, 90, and 87. We take the mean, which just add those up, divide by 5, 84, 4. We get the standard deviation also, which I'm not going to put all the calculations for the standard deviation. I already covered that in another video, but let's say it's 462, right? And then all we have to take is the standard deviation, which is 462, divided by the root of 5, and then we get a standard error of 2.07. So with this background out of the way, I think we're ready to start coding and get your notebook up, and we'll go through a few examples. All right, let's get started. What we're going to do is bring in all of our imports. So import NumPy as NP. Then from SciPy, import stats. And then we're going to import matplotlib. So matplotlib.pyplot as PLT. And I believe that's just everything that we're going to have to import in this video. Then I recommend you set up a random seed. So np.random.seed. I'm going to set a seed of 11. And yeah, once that is good to go, let's get started with our first example. So we'll say example 1, manual calc. And we're going to look at strikeouts per season. There you go. So let's set our data. We're going to say data equals, and I'm going to paste over what I already have prepped for this video. And we have 110, 112, 231, 213, 161, 123, 221, 316, 218, 219. If you want to copy it, awesome. If you want to do your own, either way, there is that. And then what we want to do is find the length. So all we have to do is n equals length. Pass in our data over here. Now we have the length of that. And if you want to see, right, just print that in. I think it's 10. Yep. Is 10 over there. Now what we want to do is calculate the standard deviation. So std dev equals np.std, and we're going to pass the data, and since we're grabbing a sample, we're going to say ddof equals 1. Great. Print that out. Print standard deviation 65.34. And then now we need to do is our standard error. So standard error mean equals our standard deviation, so std dev, and we're going to divide that by np.square root, and then inside over here pass in n. All right, and now we can just print out SEM and our standard error 20.6635. Now, this wasn't too hard, but we can make this easier. and we're going to use SciPy. So example 2 SciPy, all we need to do, check this out. So we'll see sem SciPy equals stats.sem and then data. And what you'll see if I print this out, look at that. One line of code versus all of that. Thank you, SciPy. Although this wasn't really too bad, but I'd much rather write one line of code. All right, I want to show you an awesome example here, and we're gonna use this example also to plot. And yeah, I think you guys are gonna like this a lot. So let's go example 3, and this is the example in my slides, by the way, where I showed the different sample sizes, how the standard error impacted from the sample sizes, as well as what we can calculate the sample mean. Because honestly, like by the end of the video right here, there's not enough, right? Like I want to make a better video for you guys. So example 3, marathon times. And I do hope you guys appreciate the effort that are put into these videos because they do take some time. So we're going to say marathon times equals np.random.normal. Now we'll say the average marathon is 4 hours, so 240 minutes. So we'll say location equals 240. Then what we'll have next is our standard deviation. I'll just say it's 30 minutes. And I have no idea if these are true or not for the marathon. This is just what I put over here. The marathon time is probably slower. Standard deviation is probably larger, but for this video, I think that's fine. And then if you want to see what some of these marathon times look like, all you do, marathon times, inside over here, :10. I'll see the first 10 times on here. Not that it really matters for this video, but just to show you what these look like, right? 292, 231, 225. My fastest marathon was what, like 3 hours, 17 minutes or something like that. I want to beat that. I'm not training for a marathon right now. I'm training for ultra, but regardless, awesome. We're going to have to do a little work though if we're going to get these sample sizes correctly. So let's create a function on here to compute the standard error. Then we're going to have our sample sizes and then we'll run a for loop. Probably a little complicated for this standard error video, but it's whatever. So what we're going to say is def compute standard error. Then inside over here, we'll pass in our data and sample size. All right. Then we're going to have a colon over here, and then we'll say sample equals np.random.choice. Pass in data, size equals sample size, and replace equals false. Then our standard error equals stats.sem sample, and then return se np.mean sample. Could have called it sem, but that's all right. And now what we're going to do is we're going to create our sample sizes. So we'll say sample sizes equals, and let's look at 50, 500, and 5,000, right? Then what we'll do is we'll have results. So results equals, we'll blink dictionary over there. And then what we're going to do is a for loop. So we're going to say for size in sample sizes, right? So we're going through each of these. SE and sample mean equals, and then we're going to run this over here, compute standard error, right? And we're going to pass in our marathon times. So marathon times, and then we pass in our sizes, right? And we're looking at each size in sample size. So we're just putting size over there, and we're going to say results, and then we're going to say the result for each size equals, inside over here of the dictionary, and we'll say SE, then we pass in SE, then we have mean, so mean, then we have our sample mean. So sample mean like that. And if some of this code looks a little confusing, no worries on there. I do have an error. Let me just see what my error is really quick. Should have had a colon right there. I didn't realize I didn't have a colon. All right. Okay. And now let's output our results. So output our results, we'll say for size and stats and results.items. Inside over here, we'll say print, and we're going to do an f string, sample size. Then over here, we pass in that. So we're going to say size. Then we'll have a line like that. Then we'll have our standard error. And we'll say stats SE. And we'll round this to 4 decimal places, 0.4f. Right. Then we'll have our sample mean. So sample mean. And inside over there, we'll pass in that. So we'll have over here stats mean. We'll also round that to 4 decimal places. I think that's what I had for my code. Let me close that out. Yeah, so this should be good here. Oh, I have an error. Did I have capital mean? Yeah, that's what my error is. All right, 50, 500, 5,000. You can see the standard error decreases as the sample size increases, and then our sample mean gets closer to the true mean, right? We defined our mean to be 240. First time was 245, then 239, and then 240. All right, and lastly, we'll say example for, which is viz, and we'll say sizes equals list results keys that, then errors equals, and so over here we'll say results size error for size in sizes. And then let's plot this out. So pt.figure fig size equals 8 and 5. Then pt.plot sizes errors marker equals that. plt.title, which honestly I could just copy over title, x label, and all that. Title standard error versus sample size, x label sample size, y label standard error. plt.grid true, and finally plt.show. And with that, check it out. So you can see our sample size as it increased, our standard error decreases. And yeah, standard error versus sample size. So, you know, if you didn't understand all the code on this last one, no concern. All you got to understand, we can grab the standard error mean really easily with SciPy, or I showed you the process of how we can do this manually. Recommend at least you kind of have understanding how the manual side works before jumping into SciPy, so you understand the math behind it. And yeah, just remember also as your sample size increases, your standard error decreases, and that's because your mean gets more accurate. Well, that's it for our standard error video. Hope you found some value here. If you did, make sure to subscribe to the channel. We're trying to reach 100,000 subscribers in 2025. I have a few important links down below, as well as other videos that I highly recommend you watch next. And if you want to continue watching this statistics playlist, it's going to be right over here.